we hear sounds from various sources. For example, we hear music from different instruments, barking of dogs, honking of vehicles, etc. In this slide, there is a picture of a ruler, a metallic strip, which is fixed at one end, and its free end is pressed with hand, and on releasing it, you will notice that the metal strip starts vibrating and you will hear a sound. Similarly, if you take a thin rubber band and stretch it as shown in this picture and pluck it near the middle, you will see it vibrating about its mean position. In a musical instrument, for example, a sitar or a guitar, which are called stringed instruments, the wire is plugged at some point and you are able to hear a sound. If you take a drum and strike it at the membrane, you will again hear a sound of the drum. And if you touch the membrane of the drum, you will feel its vibrations. When the membrane stops vibrations, no sound is heard. From these examples, we may conclude that the sound is produced by the vibrations in a body. If the body stops its vibrations, the sound produced by it ceases. And hence we can conclude that anything that vibrates produces sound. Therefore, we can say that the mechanical energy is always required to start the vibrations in a body producing sound. Sound is a form of energy and it is produced only in a body when it is made to vibrate. The vibrations started at one point from the source are transmitted in the medium from one point to another and so on. Thus, sound travels in all the directions in the medium. The sound waves on striking the eardrum make it to vibrate to and fro, from where auditory nerve picks up this motion as a signal and sends it to the brain. The brain thus interprets these signals as sound. So that is the introduction of the chapter sound. In order to understand how sound propagates, you need to know some important points. Sound needs a medium for its propagation. That is the first requirement for a sound to propagate. It requires a vibrating body. That means it needs a source of sound and a receptor or receiver. Now, medium is a substance that carries a wave or disturbance from one location to the another. That means it is an agency that carries energy from one point to the another with the help of its particles. And a medium can be a solid, liquid, or gas. Now, there are some requisites of medium, which means any substance which is considered as a medium must fulfill some requirements. And those are: the medium must possess elasticity so that its particles may come back after their original position, comes back to their original position after displacement on either side. That is, the particles are capable of vibrating about their mean position. Why? Just because if there are no vibrations, sound will not be able to if there are no medium particles which possess elasticity, sound will not be able to propagate. So this is the very important condition which is to be satisfied if you are considering any substance as a medium. There is one more requirement, and that is the medium must have inertia so that its particle may store the mechanical energy. As you have been told that whenever sound propagates, it is the energy which is propagating from one point to another. And the energy which is propagating is actually the mechanical energy. So the particles must have inertia. And the third and the last important point for a medium is that it should be frictionless so that there is no loss of energy during propagation. This slide is followed by two demonstrations to make you understand the concept of propagation of wave. The formation of waves in air could not be seen by the eye, but the formation of waves can easily be seen on the surface of water. There is a tank which is filled with water, and as soon as a water drop is made to fall on the tank, then disturbance is created at that place. That means the water falls at a certain point, and at that point the disturbance in the form of concentric circles called ripples is seen to be spread outwards from the point of disturbance. This you can observe clearly in this video. Now let me show you the side view of the same tank. And now you observe these ripples appear to be in this manner from the side view. Now if we place a small piece of cork anywhere on the surface of the water, we will observe that it is not moving along with the wave. This will happen because the waves are merely tossing up and down at the position. This demonstration will further strengthen your concept on the topic. I have taken a long, thin string consisting of beads. This string is fixed at one end with the help of rigid support. Now on giving a slight jerk, up and down jerk to the string, you will observe that the vibration is being transferred from one bead to the another, and therefore it appears that the whole string is oscillating up and down. A similar scenario was observed in the case of water as well. Now if you closely observe the green and the red beads, you will notice that these are only tossing up and down. This clearly shows that whenever a medium is disturbed, the particles oscillate up and down or to and fro about their normal level or their mean position, and this constitutes the wave motion. That means if this would have been vibrating or oscillating normally, then the the beads will appear to be oscillate in this manner. Kindly observe their motion carefully. In these two activities or animations, you must have noticed that there is always some mass that oscillates for a long time after it is disturbed. Therefore, when a source of sound vibrates. It creates a periodic disturbance. Periodic disturbance means a disturbance which is repeating itself after a particular interval of time. That means the disturbance or vibration has a fixed time period, and that is why the nature of the disturbance or the vibration is periodic. So when a source of sound vibrates, it creates a periodic disturbance in the medium near it. And hence we are in a position now to define the wave. Wave is a kind of disturbance which travels through a medium. That means a wave, in order that wave travels, it requires a medium. And that means this wave will travel because of the periodic motion, right? Periodic motion of the particles of the medium about their mean position, and the disturbance is handed over from one particle to another without the actual movement of the medium, which means that the medium remains at its own position. It does not move. There is no transference of the medium. It is only the propagation of energy that takes place. And the energy this wave carries is called mechanical energy. From all the discussions, we can understand that for propagation of sound, it requires a medium. Uh, and if there is no medium, there will be no vibration and there will be no sound. After this slide, there is a bell jar experiment to demonstrate that sound needs a medium for its propagation. I hope now you will be able to answer these two questions. Question number 1 is, why can't we hear explosions that take place in space? And what is the reason for this? The reason is that sound needs a medium for its propagation. But in space, there is no uh, there is no air. It is absolutely vacuum, right? So there is no medium particle over there which will carry the sound waves or energy from one point to another. Similarly, this question also, why can't two astronomers talk to each other on the surface of the moon? Now, on the surface of the moon, the density of air is very less as compared to the density of air on the surface of the earth. And therefore, even if there are some medium particles present over there, but because the density is so less that they are unable to carry the sound vibrations or sound waves from one location to another, and therefore astronomers cannot talk to each other. Now, on the basis of medium, waves can be classified into two types. One is mechanical wave and the other one is electromagnetic wave. Electromagnetic waves are light waves. Apart from light waves, there are some more waves you must have heard of, which are X-rays, gamma rays, etc. Right? These are electromagnetic waves. Okay? Now, the another type of wave is mechanical wave, and sound wave is an example of mechanical wave. Other than sound waves, there are more examples of mechanical wave, which are water waves, waves in ropes or strings. So here I am going to tell you basic differences between electromagnetic wave and mechanical wave. So I have taken here the difference between light and sound. Light is an electromagnetic wave which does not require any material medium for its propagation. And that is why even in the absence of air in space, light from sun reaches to us, right? So because it is an electromagnetic wave. On the other hand, sound is a mechanical wave which needs a medium for its propagation. Now, if you compare the speed of light and sound, you will find that the speed of light is very high, which is 3 into 10 to the power 8 meter per second. On the other hand, the speed of sound is very less as compared to speed of light. And that is why lightning is seen first and thunder, the sound of thunder comes later. So there can be, however, more differences between light wave and sound wave, which is sound wave is a can be longitudinal wave as well as transverse wave, and light wave is always transverse in nature. But these two differences will be dealt only after you are taught about the types of sound waves. So we'll come back to this difference later. Children, now this is the summary of whatever you have studied so far in this chapter. So the characteristics of wave motion are: wave is a periodic disturbance which needs a medium for its propagation. It always travels at a constant speed in all directions. However, there is one factor which may affect the speed of the wave, and that is the nature of the medium. However, later in the chapter, you will study that there are some more factors that affect speed of the wave. But for now, you just understand that the speed of the wave depends upon nature of the medium. In wave motion, the particles of the medium do not move. That means the medium does not move as a whole. It is the transference of mechanical energy that takes place. Wave motion, mechanical wave motion is possible only in that medium which possesses inertia, elasticity, and should be frictionless. So that's the summary of the taught part.